Okay, now question 4. So one thing I want to do real quick is just refer back to my original lecture videos. Question number 3, and I put it right here for you. It's the second of the 4 types that I outlined in the video, right? So we're comparing a sample to a population. And if we know the population standard deviation, that's type 1. We don't in this case. We don't know the population standard deviation. We only know the sample standard deviation, that's type 2. So in question 4, we're going to be using that type 1. Again, I put a lot here for you. Please make sure you're reading this stuff. So the question here is, we have VSU undergrad students with an average high school GPA of 3.13 with a standard deviation of 0.11. And we're interested in the differences within majors, so this researcher takes a sample of 65 students in sociology and found their average high school GPA, their mean high school GPA was 3.48. So test for the differences between the sample mean and population mean using a hypothesis test. So again, this is exactly the same thing as question 3, except you do know the population standard deviation. Question number 3, you didn't know it. You only knew the sample standard deviation. Question number 4, you know the population standard deviation because you can get it from VSU's website. Here it is right here. There's your population mean. So let's go through these things again. Just like with question 3, you're always going to have these 5 things, and I've written them down for you to help, but you're not going to know one of them. So do we know the population mean? Yes, we do. Do we know the population standard deviation? Yes, we do. Do we know the sample mean? Yes, we do. Do we know the sample standard deviation? Well, in this case, we don't. But even if we did, because we have that population standard deviation, it's a Z. And then we have our sample size too. So let's fill this out. Your population mean is going to be 3.13. Population standard deviation is going to be 0.11, 0.11. Sample mean is going to be 3.48, and sample standard deviation, we don't know. And our sample is 65 people. Okay. So again, the key is, do we know this or not? That's the main difference. But we're still doing the same thing. We've got this huge population. Our population is just VSU students. And then we take this little sample, which is a sample mean of GPA for Soc. Okay, and 65 people. So always start with writing down your assumptions, and I'm going to leave that to you. That's straight up written in the slides. That you can find on your own. Filling in the values for the variables, I just did that. State your research and null hypothesis using a two-tailed test. So again, you're always going to have your null and research hypothesis, and your null hypothesis is always going to be the same. Mu is equal to 3.13, mu for Soc. So the mean, the true population mean of sociology students is equal to the overall population mean, right? So it's the idea, it's basically saying, are sociology students, GPA-wise, are they the same as everybody else? Or is there something different about this particular sample? That's your null hypothesis. Since you're doing a two-tailed test, it's not equal to. One tail you want to do greater than or equal to, greater than or less than, depending on the question. If again, like I did in question 3, where I had a theoretical reason to believe that one was less than the other. In this case, I just asked for a two-tailed test, so I'm not interested in it's less than or greater than. It could be either. My hypothesis is just that it's not equal to, so that the mu of Soc students in terms of their GPA is not equal to 3.13. Basically, looking at it, you can say, well, is 3.48, is it higher than 3.13? I mean, it, numerically looks so, but again, this is a sample mean. And sample statistics are always bounded by confidence intervals. We get a point estimate, but we're really interested in the confidence interval because there's always sampling error. So the idea is to see our null hypothesis that there's no relationship, that they are equal to each other. It's just that there's no difference in the Soc mean than the overall population mean. And the research hypothesis is that the Soc mean, that there is a difference, that it's not equal to. Okay? So now you got all your stuff here, and I've specified to use a 99% confidence level, okay? Alpha equals 0.01. And I told you, I really was trying to help you guys out that you want to use a Z distribution, but I didn't even have to tell you that because the fact that you didn't know this, the fact that you knew your population standard deviation but didn't know your sample standard deviation, you know you got to use Z. Okay? So, state the research, and all right, we got that. Then using alpha equals 0.01, compute the test statistic using a Z distribution. Okay, that's easy. Similar to before, here's our calculation for a T test statistic. And this is what we did in question 3. And then here's our calculation for the Z statistic. And this is what we're doing in this one. Now, the only thing that's different here, if you can see, is just that in the T, we have the sample standard deviation. In the Z, we have the population standard deviation. And you know that by the central limit theorem, as long as we have a sample size that's large enough, typically above 50, you can use that sample standard deviation to substitute for the population standard deviation. However, you use the T statistic, you would use a T if you don't know that population standard deviation because it's a more flexible distribution. Again, if you want to hear more about that, go back to the original videos in terms of, explaining what the T distribution is. But just for now, we're focused on this guy. So here's your equation here. So here's your equation for the Z test statistic. Okay, so it's just Z is equal to the sample mean minus the population mean divided by the population standard deviation over the square root of n. Sample mean 3.48 minus the population mean 3.13 divided by the population standard deviation 0.11 over the square root of 65. And that's it. And then that's how you calculate your Z test statistic. And you always, in order to determine which, if your null versus your research hypothesis, you compare your test statistic to a critical value, always and forever. Okay, so I'll let you, you can work that out. The math is on you on that. But you'll get this test statistic and you'll compare it to a critical value. How do you know the critical value? That's determined by the confidence level that I asked for specifically. So I want I want a confidence level of 99%, but I'm using a two-tailed test. So let's think about that a little bit. If you think about this distribution, 99% means that I want 99% within the distribution and 1% outside of. Basically, it's saying that we're 99% sure that those differences aren't driven by chance and that it truly is outside of what we'd expect the mean to be if they were equal to each other. So if 99% is within these bounds, now it's easy with a one-tailed test because it would just be 1% above, but since it's a two-tailed, it's actually going to be 0.5% below and 0.5% above. Now, if it was one-tailed, it would just be 1% either above or below, depending. But since we're doing a two-tailed test, which is the not equal to, we have to account for it being above and below. All that is to say is that you're going to find that, so if you convert the 0.5% into a proportion, it's 0.005, right? So is this the area beyond Z or the area between the mean and the Z? Well, it's the area beyond. So you're going to look in your Z, you're going to get the standard normal table out. And we want to find where the area beyond Z is equal to 0.005. So I'm looking here, 0.005, going down. Got to go all the way to the end. Obviously, it's a really higher number. 0.005, and it's right about there. 2.58. Okay? So that's what you'll use for your critical value is equal to 2.58. Okay? So going back here, you'll get your test statistic. If your test statistic is greater than 2.58, then you reject the null and accept the research. Soc majors do have a different GPA than the rest of the students at VSU. If you get a test statistic and it's less than 2.58, and then you can't reject the null. You have to accept the null. We didn't reach that point. It's like, here's the 2.58 threshold. We keep getting above. If we can get above that, then we know that our research hypothesis is true. We can say they are different. But if we can't get above that, then we can't conclude that they're different. We'd say Soc majors and Soc majors have the same GPA as everybody else. So you're computing the test statistic, that's your equation here, and then your conclusion is going to go down here. So, what are you testing? You're testing to see if Soc majors have higher high school GPAs than the entire population. If your test statistic is above that critical value, then you reject the null and you go with the research, and you can say they are different. If not, then you can't. Then the null is that if the test statistic does not, if the test statistic is less than the critical value, then you can't say they're different. You have to go with the null. Okay? And then you conclude about that to see is that, are Soc majors different in their high school GPAs? If you can say the null hypothesis is, if you can reject the null hypothesis and go with the research because you have a really high test statistic, then you found that they are different. Soc majors have a higher high school GPA than everybody else. But if you find a test statistic and it's lower than the critical value, then you can't say that. You can't say with any degree of certainty that they're any different. So you're 99% confident that they're not different, that they're the same. Okay? That's question 4.